Kia ora. Okay, so pretty much when we left, we'd worked out the intersection between YAB and YDH, so we could find this new point M that we defined. So we'd found M, and pretty much I realized that what we're going to be doing is exactly the same stuff to find N. So to find N, we're going to find the equation of the line AB and the equation of the line HC, and then we're just going to set them equal to each other, and then we'll find the intersection, and that will be N. And then it's just a whole lot of working out distances once you know what the coordinates M and N are. So I'm not going to go through that today. I'm just going to show you briefly how I just started doing it, and then I was like, why am I doing this? I'm wasting your time and my time. So pretty much I found the gradient of H to C, and I found that was negative 1.029. I then found the line of YHC using this formula with the gradient and one of the points, the easier of the points. So I found the equation of this line. And then I figured out that, so N is going to be the intersection where YHC equals YAB. We found YAB before. So I set them equal to each other. I did some algebra. I'm just going to show you quickly what I did here. Notice how it's 0.125x on the right and negative 1.029x on the left. So what I do is I added 1.029x to both sides, and I brought it over to the right so I have a positive x value. And then I just brought all of the numbers onto the left. I then divided by 1.154 to get that the x value of N is 0.209, and then I substituted that value in to my YAB equation. You could do YHC as well, but YAB is just a little bit prettier. And then I get my Y value for N. So I found the point N, and then what I did was I just used the distance formula between M and N. And so the distance is this. I'm showing you how I typed it into my calculator down here. I found like a scientific calculator with a Desmos. So I'm just showing you that I do a square root, a bracket, then another bracket. I do the x2 minus x1 squared, and then I add y2 minus y1 squared. So that comes out with this distance. And I was going to go through and do the other distances, and I'm like, can't be bothered. So pretty much to get the merit for the coordinate geometry, you would just go and, now that we've got this distance, you'd then work out what is the distance of NC, and then you'd work out what is the distance of CD. Now I am actually going to need CD for the next one, but we'll get to that when we come to it. So what you would also need to do in the internal is you'd need to write a statement saying, you'd add all of those distances together, and you would say the perimeter of the covered pool is, and then however many units. So you need to do that in NCA to get the grade. So the next one is actually a question about, it says, investigate the shape of the covered pool and find its area. So what we're going to do is I'm actually going to use my mouse for this. It's a bit easier. So we'll have a look at this question now. Okay, you can come down here. You can come down here. So what we're going to do now is we're going to have a little look, and we're going to try and find the area of the covered pool. So it might be useful, if we're finding the area of the covered pool, we're probably going to need those coordinates that we found before. So I'm going to grab those because they might come in handy. Do a real beautiful cut job of that. Let's grab that and bring it down here because it's going to be useful for us. Right, so we know that M is here. Let me get back into my pen mode. So we've got M set up here, and we've got N set up here. And we're trying to find out what the area of this covered pool is. Now, you'll notice that it's some sort of quadrilateral. Now, we need to come up with a strategy, and we've actually already got the merit on the coordinate geometry, so I think it's pretty obvious that we're going to be using trigonometry for this. And if we're dealing with trigonometry in level 2, it's generally going to be about a non-right angled triangle. So when I look at this shape, maybe I'll do the shape in green. So we've got this shape here. one day I'm going to be able to do these real straight, hopefully. And we're trying to find the area this time. So when I think area, I think of that formula from trigonometry for the area of a triangle. But in order to use that, we're going to need to find an angle, and we're going to need to find some side lengths. So there's a couple of ways you can go about this, and the students in my class had a couple of cool little methods. One of the methods was slicing this down here, but better, and making it into two non-right angled triangles, this quadrilateral shape. For you to do that, you're going to need to, well, we know this distance here, we know this distance here from before, but we don't know this angle yet, and we're not going to have a way to work out that distance without an angle. So you can't get straight into that. So we're going to need to think of a different strategy. So how could we find an angle in here? So the thing is, this is overall a big triangle, and the big triangle shares two angles. This one here, alpha, or the theta A, and then also theta B. So we can find these angles because we know that this is a big triangle here, and these angles will also be the same angles that appear in the quadrilateral. So what we're going to do is I'm going to draw a bit of a new picture, and we're just going to take the details that we need. So this is a pretty good technique when you're in the internal to like draw mini diagrams and just make it obvious what you're talking about by labeling corners. Right, so I've got this new shape that I'm doing, and I've got D, which is -5 and 1, and I've got over here, I might as well color that in, I've got C, which is 4 and 2, and I've also got up here H, which is some nasty number, so I'm just going to make my thing quite close to it. -1.14 and 7.29. Sometimes simplifying it down to just the basic shape is going to make it way easier to apply the rules. So here, we're going to have to find all of these distances, and it's a big waste of time having to work out all of these distances over and over again. So I wonder if there's like a calculator online that does this, because I don't want to waste you guys' time just calculating distances. Calculate distance between 2 points. I mean, you guys have seen how to do this. I'm gonna go that 2D distance calculator. That's what I'm talking about. Let's save some time. You serious? Oh man, Macs. Gotta love them. Gotta love Macintosh. I don't know. I want this over top of what I'm doing. Mac, that's what I want. Yes, show me that. Is this in like a different window? Oh, it's in the full screen mode. Okay. Now we can do it. So let's just get these distances using some cheap methods. We've got -1.14 and 7.29, and down here we've got -5 and 1. Calculate that. So that's got a distance of 7.380. So yeah, normally you would actually have to work this out. DH equals, and then DHC equals, what changes here? It's 4 and 2 instead of 5 and 1. So go 4, 2 and calculate that. 7.376. Do you know what's funny about this? I imagine this was meant to be an isosceles triangle, but you know how it goes. Rounding to 2dp, whoever wrote the thing must have been rounding their points to 2dp, so it's just what happens. So don't be too worried if your numbers don't come out beautifully. D, D, C, and this having a close of the brackets annoying me a bit. 9.055. Okay, so we've got these distances now, and we can work out now an angle, and we've got to work out which angle is going to be the most useful. So let's just, it's always good to come in with a strategy. If I find this angle here, then I will be able to use that angle with this distance and this distance to find the length here using the cosine rule, which is going to be pretty helpful. And then I'll have that, I'll have an angle, but I will be lacking, I don't know how to do this little triangle here. Oh, you know, because I'll have a distance and a distance from before and another distance, and I'll be able to use that to find an angle. Yeah, it means that I'm going to have to go over and do some more distance calculations. Okay, so let's say I'm finding this angle here. I'm just going to call it, what is it opposite? HC. I'm just going to call it angle HDC. Angle HDC. So to work that out, I'm going to need the cosine rule. So let's go and grab that. Cosine rule, come to me. So when you're working out an angle, you're going to need to use the whatever. My policy is try and get the unknown as far to the top left as you can. So see how here we've got. Did that not work? See how here we've got cos A on the left. So that means it's the good one. I hope this is pasting. No, it's not. No, not that one. I want you, please. Okay, I'm going to change Command Shift 4. Grab that. You can come with me. And you can go down here because I want to show you guys the cosine rule. Because I'm going to use this rule to solve this. So let's go back to my pen. So I'm going to need to, the angle's unknown. So first of all, let's rearrange it to get cosine set up on the other side. So the angle HDC is going to be equal to, so to get rid of cos, you do the cos inverse. It's going to be cos inverse of, now B squared and C squared are the adjacent side lengths. So it's going to be 7.38 squared, and then I'm going to add on 9.055 squared, and then A squared is the opposite. So see how you got capital A, lowercase a is going to be whatever's opposite. So opposite, I'm going to go minus 7.376 squared, and that's all over 2 times 7.38, oopsies, 7.38 and 9.055. I'll try and close that off. A little bit ugly, but that's all good. Alright, let's get this little calculator up. Hopefully I can show you guys how to do some funky calculation stuff. So, what function do I need? I'm going to need the cos inverse. Let's go back to here. So what I'm going to do is I'm going to put everything on top in a bracket. So I'm going to go 7.38 and I'll square it plus 9.055 and then I'll square that. Now minus 7.376 and then I'll square that. Now I'm going to need to close the bracket and I'm going to do divide. It's a little bit annoying because it's not going to show you what your calculator would do. Your calculator would just have a fraction symbol that would be between it, and then so you would open another bracket here and you'd go 2 times 7.38 times 9.055. Those are dot multipliers. They're way better than multiplication symbols because it's way less writing. So if it's a full stop in the middle of the line, it just means it's a dot multiplier, just the same as multiplication. Let's close this off, and then that should give me my answer over here. So the angle, does it make sense to be 52 degrees? Yeah. Let's go 3DP. 52.126. 126 degrees. Okay, so now I've got this angle sorted at 52.126. Now I can use that angle now in my quadrilateral split that I'm doing. So what I'm going to do is let's draw another picture down here with the new thing that we're trying to work out. So now we're going to this, and we know now what this angle is. Let's get rid of my pen. So we now know that this is 52 point, and I need to get a short-term memory, 126 degrees. Now, when we draw this line in here, let's pretend that they just met over there, and we have this distance from before, the distance of D to M. Let's grab that from before. Distance of D to M, it was 5.4. So this is 5.4 units. So we've got this distance. We didn't find the distance of D to C. Oh yes, we did. 9.055. 9.055. So we've got distance, and an angle. We could now find the area of this part, but I think we're going to need the distance between M and C first. There is so much distance calculation in this, and I think it might be the same in the actual assessment. It's pretty rough. Distance, MC. Did I not work that one out yet? No. Okay. I'm totally gonna cheat. So we got M there and C there. Let's go back to my little cheat thing, because I can't be bothered doing this, and you can't be bothered watching me do the same thing over and over again, surely. Okay, so we got M here, negative 2.176, comma 5.603, and then down here we've got 4 and 2. So that comes out at 7.150. So that's 7.150. I don't know why I put that right there. Beautiful. 7.15. So that's going to come in handy, because when we've got this distance here and that distance there, we can use that to find another angle. And then once we've got that angle, we can find the area of that. And then we've got two sections, and yeah, the answer's just going to pop out. Okay. Man, this is convoluted and messy, and I apologize for that. So we're working out the area of that little triangle, this one here, and that's DMC. So I've got like a little shorthand that I do. I go triangle DMC, and I use this for area. So the area of a triangle has a formula. My snipping tool wasn't working before, so I'm just gonna grab it like this again. I want you sort of there. Get the pen mode off. Cool. And we'll put that just up there to help us. Always have the formula sheet handy. You're going to get one in the thing, so you might as well use it. Okay, so it's going to be half and BC. Let's find out what BC are. So for this triangle we're doing, B is 5.4, so you just get the adjacent ones. 5.4 and 9.055. And then you do sine of the angle. And we got the angle, 52.126. Oh, that's so messy. Do I change it? Nah. Let's get our calculator out. So we'll clear that. So to do this, half is sometimes better expressed as 0.5. Matter of opinion. So we're going to go 0.5 times 5.4 times 9.055, and then sine 52.126. We'll close that off, and it's 19.299. And you're going to have to do units squared, because it's an area that we're finding. Is it a logical area? Quite. It's a, yeah, more than a square. Yeah, looks like a pretty reasonable answer to me. 20 squared units with that angle and those two side lengths. It looks pretty good. Okay, so that's DMC. Now what we're also going to have to do, I feel like I should just skip the next one. So we're going to need distance of MN, distance of NC, and distance of MC, and you'll use those three distances and the cosine rule to find this angle, angle MNC. Once you've got that angle, you can use these adjacent sides here to find the area of this. To be honest, it's just a waste of time, so I'm just going to stop and leave that as an exercise for you guys. Okay, finally, task 3. John is claiming that the area of the uncovered pools makes only 15% of the area used for all 3 pools. Investigate this claim. Okay. This is a nice little bonus question with a sector. It's just a perfect sector, actually. So it makes it, this is actually a pretty easy question. It's just getting you guys to use sector laws. To find a sector, you just need to know this angle, and you need to know these lengths. And these lengths we've already worked out are around about 7.38. It has to be the same. If that's 7.38 in a sector, this must be 7.38. So we just got to work out what that angle is. And to work out that angle, it's going to be this triangle. We're going to go back to this triangle. Let's just do it here, eh? So to find this angle here, which is angle DHC, you're going to need to use this as your opposite in the cosine rule. Let's just go straight into the cosine rule. I've already shown you guys how to do it, so let's just do like a quicker version, eh? So we're going to use that rule in that picture, so I'm going to need to make myself a little bit of space. That rule, that picture, cool. Clear all. So the angle is going to be equal to the cos inverse, because we're dragging it over. We're then going to do another bracket, so I can get what's on the top of the fraction, and it's going to be b squared. Now b squared is an adjacent side, so 7.376. And then we are going to square it, plus the other adjacent side, which should be the same, but poor rounding is going to mean my answer is going to come out different to yours as well, by the way. But it's going to be very minor differences. And then minus whatever angle is, or whatever side is opposite, so 9.055, and we square that. Close off that bracket. Whack a divide by in there, or a fraction, whatever you like doing on your calculator, and then we just do it by 2 times, and then the 2 adjacent sides, 7.376, and then multiply that by 7.380. Close off this bracket just because we're pros. So we now know that this angle is 75.708. You would normally need to show your working, but you can just follow the video and pause it if you didn't get that. So we now know this angle. Can I fit it in there? 75.708 degrees. Oop. And these are units, because it didn't specify if it's meters, but it's clearly meters, because who's got a pool that's 7.38 kilometers? Actually, maybe that is a thing. Okay, we are going to need to grab a rule, which is the sector. And copy that. Go back down. Whack it in there. Where did that get whacked in? I don't know. Whack in here. Nope. Thank you. Where am I going to find this? Screenshots, desktop. Can we be bothered? Can we be bothered? No, we'll just do it again. Sector. This one. Yes, you. Grab it. Control C. Control C. Click on it again just in case. Control C. Come down with me. Yes, area of sector. Cool. Okay, so this sector here, it's like, this is one of the easiest things to work out. It's just like a percentage of a circle. So we do pi and the radius is 7.38 and we square the radius. So this is the area of a circle, and because it's only 75.708 out of 360 of the circle, that's what we just write up here. So 75.708 over 360. And that should find us our answer. Pretty straightforward. Okay, so where's pi? I mean, do we know pi by heart? No, there's better things to do in maths than learn pi off by heart. Pi times 7.38 squared multiplied by 75.708 divided by 360. So that is 35.983. And that's units squared. Right, so that's the, what is this? The area of all three pools. Now what they want us to do, John is claiming that the area of the uncovered pools makes only 15% of the area used for all three pools. Okay, so what I would do is I would just find 15% of that. So to get 15% of 35.983, what we do is we just go 0.15 times 35. Hello, 0.983. 0.15 times 35.983 is 5.397 units squared. Okay, so pretty much what you want to do is you want to find out what the uncovered pools area is. So what you're going to have to do for that is, and can we be bothered doing it now? I mean, we just find the area of a triangle using that same thing. We'll quickly do this one because this one's pretty easy. 7.38 and the angle is 75.708 degrees, and that's 7.38. And we know the area of a triangle, so this is triangle, what are they, DHC. Triangle DHC, and the area is just half, and then we just do 7.38 times 7.38, and then it's sine of 75.708. Let's just do that. That's actually 7.38 squared. I'm just going to save some time. Sine. Okay, so that makes the area of the triangle 26.389. So that's the area of the triangle. So I'm just going to quickly draw a diagram. So if we have a sector and we minus off the triangle, what you're left with is a segment. That's just like the base bit, because this bit's been taken away, right? So we're left with this, which is called a segment. You don't really need to know that. But pretty much now we can find out. So we know that the sector overall, we'll do it in blue. Sector overall is 35.983. And then we minus off this triangle, which we just worked out, 26.389. 35.983 minus 26.389. And that gets us 9.594. Am I getting better at remembering these? Okay, so this is the area of the segment, but now we're also going to need to find that little triangle at the tip. So remember how our shape's sort of like this. So we've found this little blue bit, and that's accounted for. But what we haven't found is this green triangle here. And I don't want to waste you guys' time, so I'm just going to sort of stop now and just explain the rest. So pretty much, what you're going to do is you've got, from all of our prior working, you know M, you know N, you know H. That means you can find a distance here, a distance here, and a distance here. Once you've got three distances, you can use the cosine rule to find an angle. In fact, we've got an angle. So you can just grab that angle that we grabbed from before, that, what was it, 75.708. And once you've got that angle in these, oh wait, we can do this super fast. I just realized. It's just 7.38 minus whatever that MD distance is. Have we found a distance for MD? Let's do it. MD. This is what it's going to be like when you're doing your assignment, by the way. You'll be like rushing through trying to find. Do we find the distance of MD? DM. Oh yeah, distance DM, 5.4. Sick. So we know that this is 5.4. I'm just going to draw a diagram. Pretty much we've got this big thing, and at the base is D, up along the thing is M, and right at the tip is H. Right, so this shape goes that way or whatever, but we're only interested in this. We know that this is 5.4, but we know that the overall is 7.38, was it? I think it was 7.38, yeah. We know overall is 7.38, so we can use that to find out that this is 1.98, if my calculation is correct. Yes. So all I did was 7.38 minus 5.4, so we now know this is 1.98. So our little green triangle, I'll just draw a little diagram for it. We now know that it's 1.98, and we know that this angle here is 75.708. And we know that the other one, is the other one going to be exactly the same? No, it's totally not. Dang it, I can't be bothered working it out. Pretty much, you would have, if you weren't lazy like me, you would have worked out this length, and you're going to need to minus that part off. Oh, let's just do it in that little calculator thing. If only you guys could cheat like me. Okay, so we know what H is. H is negative 1.14 and 7.29. Now we just need to remember what N was. Where did I put N? So it's 0.209 and 5.901. We'll calculate that. So that distance is 1.936. I knew it wasn't the same. 1.936. Okay, so now we've got two things and an angle, so we know that the area of triangle, and this is MH, we know that MHN is equal to half times 1.98 times 1.936 sine of the angle, which is 75.708. Let's have a look. Clear that. 0.5 times 1.98 times 1.936 sine. If you guys say sin, you're an absolute sinner. And I don't like puns, but that's just facts. It's sine. Okay, so the area of that is 1.857. And that's units squared. Okay, so we've got that little one. We've got the segment. So we've got mini green triangle. We've got the segment now. Segment plus little mini triangle. So that means the uncovered pools. So uncovered pools equals, you know, do all the working out, sadly, 1.594 plus 1.857. Actually, it's not sadly, because so many people make blooming little errors doing this. And as a teacher, we can go and check and be like, oh, they just made a calculation here. 594 plus 0.857, which makes that 11.451. 11.451. Uncovered pool's area is that. Now, we already worked out what 15% of the overall one was, and that was 5.397. It's not even remotely close. John's an idiot. This number is greater than, well, what was it? 5.397. Units. So John is wrong. Let's find out what it is as a percentage, just for a little refresher for you guys. So the total area of the pool is 35.983. And the little pools are 11.451. So what we do is we just divide that and then times by 100, and that should give us a percentage. 11.451 divided by 35.983, we'll times it by 100, get ourselves a percentage. Okay, no, I didn't do my bed maths properly, sorry guys. So it's actually 31.823%. Of the three pools are made up. Uncovered pools. I don't know. I'm not an English teacher. No, that's a bad excuse. I know English. Okay, so yeah, apologies if this wasted your time, but this is, you need to put your answers, this is so messy now that I'm looking back on it. It's late. This is what you're going to have to do to get an excellence. You have to like join all these skills together, and you have to somehow do this in a very limited amount of time. So it's a lot of practice and just being real quick at typing it into your calculator, and having like a clear strategy is really important going into it. Have the formula sheet ready. You don't want to try and memorize the formula. It's kind of pointless. You're better off just letting your brain just be really systematic after you've come up with your strategy, so you know what you're going for, and then you're systematically working towards that. That's the only way you're going to get to your excellence. Okay, cool. I hope you have a good night.